We're given a profit function, P of X, where X is the demand, and we're asked to use this function and use the marginal profit to determine the approximate change in profit if we change if the demand changes from X equals 200 to X equals 210. In other words, if we have profit for X equals, well, if we have a demand of 200, by how much will profit go up, change? It doesn't necessarily go up, it could go up or down. By how much does profit change if we increase the demand by 10? Excuse me. Now, the marginal profit, of course, is what? It's the derivative of the profit. It's the rate of change of the profit. And the derivative of this profit function is very easily calculated. It's negative 4x plus 4,000. And again, if everybody is in good shape with calculating derivative of this type of a function, but if you happen not to be, make sure that you remedy that. To use the marginal profit to get the change in the profit, you simply multiply the marginal profit, which is the rate at which profit changes with respect to demand, by the change in the demand. And when you do that, you're actually just using the differential. Differential says dP, the change in the profit, is P prime of X, the rate of change of the profit function with respect to X, multiplied by the change in X. Okay, so in this case, we have our P prime of X function here, and we have a change in X of 10. Okay, well, we also know that X is 200, and it's going to change by 10. When X equals 200, the marginal profit, which is again the rate of change of the profit with respect to the demand, is easily found to be 3,200. Just plug in X equals 200 here, and you can do that in your head, you get 3,200. Okay, so marginal profit is 3,200, P prime of X is then 3,200, P prime of 200, and in fact, actually it wouldn't hurt to write that calculation out. That's, just to be sure we understand, that's P prime of 200 times your dx, which is 10. And P prime of 200 is the 3,200 as we've just seen. Multiply that by our dx, which is 10, and we get 32,000, and that's our approximate change in the profit. Now, it's worthwhile to understand this on a graph. Now, this is not a very accurate graph of this profit function. But, of course, the profit function does have a y-intercept of negative 10,000. We get, well, we depict the x value 200, and we've got two x values marked here. This one, the first one, is our 200. And we have a change in x of 10. Now we have, for the x value 200, P of 200 is going to be the y value. So this point here is the point 200, P of 200. We don't really care what P of 200 is, because all we're trying to do is find the change in our profit. So this is the point 200, P of 200. We have our tangent line. The slope of the tangent line, well, the tangent line has a slope equal to the derivative of the profit function, which is just the marginal profit. So the slope here is your marginal profit, which is the rate of change of profit with respect to demand, and that's P prime of 200. And that is the 3,200 that we calculated previously. Now we want to find the approximate change in P. Well, the approximate change in P is from here, the profit at 200, to the profit if we change by 10. Using the tangent line, we see that we're going to overestimate the profit. If we understand that this is an upside down parabola, we understand that if we move 10 units in this direction, we're going to end up above the graph because the graph is concave down. Okay, so we have the approximate change in P being from here to here. And that approximate change can be calculated by multiplying the rate of change by the change in X, the rate of change of profit with respect to X by the change in X. In other words, by multiplying the marginal profit by the change in our demand. Now you might well ask, with the technology available to us, it's really easy to just evaluate this profit function at 200 and then evaluate it for a demand 10 greater, evaluate it at 210 and subtract the 2. And you get an even better result. Two reasons that we might not do that, and two advantages to using the marginal profit. In the first place, it probably doesn't make much difference. If you got a small change in demand, you're going to get a very good result for your predicted change in profit. The other thing is profit functions are just the way we expect the profit to change. There's going to be plenty of uncertainty in exactly how much change there's going to be in the profit, so that it doesn't do any harm to have just a little discrepancy between the approximate change and the exact change as it would be predicted by this not very exact profit function. Now, the real advantage is that by thinking in terms of marginal profit, the rate of change of our profit with respect to demand, and our change in demand, we don't have to think about the profit function. So it's really a thinking thing. We can think that this 3,200 represents the rate of change of profit with respect to demand. That's what we call our marginal profit. It's the extra profit we get for every additional item. And that's a very useful quantity to have in our heads when we think about what we're going to do. Okay, so now we know that as long as our demand is around 200, every extra bit of demand is going to give us an extra $3,200 of profit. Very important thing to understand, and not at all obvious if you just have the profit function, but very obvious if you have the marginal profit, the derivative of the profit function. So now I can think, okay, marginal profit's 3,200. If we increase the demand by 10, that's going to increase the profit by about 3,200 times 10, or 32,000. Okay, that's the kind of thinking we want to do, rather than, well, let's see, if I put 200 into this quadratic function and then I put 210 into the function, I'm going to get this. Well, what if I want to change it by 5 units? Then I have to do all these calculations over. But if I change the demand by 5 units, or if I think about what's going to happen if the demand changes by 5 units, I can just say, okay, well, demand's going to change by 5 units, $3,200 for every unit, multiply that out, get $16,000. So I can play around with different scenarios without having to mess with this slightly more complicated profit function. And of course, thinking about these things really depends on being able to do a little simple mental arithmetic. Now, if the numbers get really complicated, I can't do that, but with simple numbers like this, and when I'm just thinking about how this business is going to evolve, I can use simple numbers to approximate things, which I can then, after I've thought about it a little bit, check out with the exact figures. So it gives us, again, a simpler mental picture to play around with if we can do our marginal profit function.